Our project topic for PCE is sampling and reconstruction of an analog signal using MATLAB. Now, what is sampling? Sampling is the conversion of a continuous time signal to a discrete time signal. The sampling process is performed because in pulse modulation and digital modulation systems, signal to be transmitted must be in the discrete time form. This signal then needs to be reconstructed back to the original signal from its sampled version. Reconstruction is the conversion of this discrete time signal into a continuous time signal. Now let's talk about the program we have executed in MATLAB. We first began with assigning a variable t whose step size is 1 to 50. We then move ahead to create the modulating signal. The modulating signal is generated using the sine function whose frequency is given as 0.02. We now use the subplot command. Subplot divides your figure window into m number of rows, n number of columns, and gives you the position p of that particular signal or the wave that you want to show. So here subplot is of the format m comma n comma p, where m is your number of rows, 4 as you can see, 1 2 3 4. 1 is the column, as you can see there's only one column, and then you see 1 is the position. So here your modulating signal is at position 1. Then you have plotted the modulating signal using plot command t comma sig. Sig is your signal, and you've given it a title, that is modulating signal. Now you move ahead to create the carrier signal. Now for creation of carrier signal, we have used sine function with frequency 0.1, as you can see, and then we have checked the conditions that if the value of sine wave is less than 0, then it is assigned the value -1. If it is greater than 0, then it is assigned the value 1, and if it is equal to 0, then it is assigned the value 0. After you end this if, you go back to your subplot command, and now here the only difference is you have incremented the position by 1, that is now it is position number 2. So as you can see on your output window, you can see carrier signal is generated at the second position, and then now you plot your carrier signal using the plot command, and again you have given it a title to get a clear picture on your figure window. Moving ahead, our third part of the program is creation of the sampled signal. Now for creation of sample signal, we have combined the carrier and modulating signal by using for and if else loop. Here we have checked the condition that if my carrier signal is equal to -1, as you can see, if x of I is equals to -1, then the sine signal will be 0. And if it is 1 or 0, then the sine signal is supposed to retain its value. Now you go on to the subplot command, where you've given it a position, that is position number 3. As you can see on the figure window, your sine signal is generated at position number 1, 2 and 3. So at number 3. Now you go back to your program, and again for generation of the sampled signal as the output, you've used a stem function instead of the plot function. And then again you've given it a title named sampled signal. Now you move on to the fourth part of our program, that is reconstructing the signal. For this reconstruction, what we do is wherever we have lost the sine value, that is, as you can see, if sine sig of I is equals to 0, that is whenever your sine function becomes 0, you want to retain its value at that positions, and hence you've used the same sine signal that you used in the modulating signal, that is the same frequency. Now let's go back and check if it's the same frequency. So here it is 0.02, and also for the modulating signal, yes, we've used the same one, hence you've used the same frequency. And then you again use your subplot command, where you've given the fourth position to the reconstructed signal, and you plot it using plot and give it a title. Hence this was our program for the sampling and reconstruction. Now let's go and check the output ones. So as you can see, the modulating signal is a sine signal, and the carrier signal, as you can see, where we check the condition that if the value of sine wave is less than 0, then it is assigned the value -1, and wherever it was greater than 0, it is assigned the value 1. As you can see, so 0, 1, 0, 1, 0, 1. And then now moving on to the third one, which is your sampled signal. You can see that we check the condition that the carrier signal is equals to -1. Wherever it is -1, there you've got your sampled signal as 0. And whenever it is 1 or 0, it has retained its value, and hence you've got a proper signed signal. Now moving to the fourth one, where you've used the reconstructed signal, you can see that you got the exact same modulating signal that you began your program with on the reconstructed signal. Hence your reconstruction is now successful. This was our program for sampling and reconstruction of analog signal using MATLAB. Thank you.